Hi, this is Kristen at SDM, and I just want to give you a little report about what we did this summer. We had some really fantastic lessons, digital art and Legos, Scratch, Tinkercad, really popular. Small group lessons of no more than 4 students. Each lasted an hour and a half to 2 hours, and we had multiple skill levels for each kind of lesson. Here are some of our teachers explaining to you what those lessons really looked like.
Hi there, I'm Thomas from the SDM Foundation. Today I'll be giving you a tour of both LEGO Essentials and LEGO Spike. We'll walk through how to get started with both programs, and then I'll show you 2 projects we've worked on, the Ferris wheel from the Essentials kit and the Robot Dancer from the LEGO Spike kit. So let's jump right in. So let's start with Essentials. It's geared towards younger students. It focuses on basic, easy builds to convey engineering concepts, and it uses color, sound, and movement-based interactivity in its programs. A good example of this is the light matrix, and it also includes basic programming concepts like loops, counting, and word problems. So when you open up LEGO Spike, you'll see this screen right here. It's divided into Essentials and Prime. We're going to go with Essentials and go to Units. We're going to pick Amazing Amusement Park, and we're going to scroll on down till we find the spinning Ferris wheel. We get a word problem. It's about the team. They want to go on a ride together. But when they find the Ferris wheel, it's not stopping long enough for all of them to ride. So now we do the build, and I'm just going to flip through this very quickly. So here's our servo, here's our battery, here's our light matrix. Starting to come together now, looking a bit more like a Ferris wheel. There we are, completed build. Now we have to build the team. So we got 1, 2, 3, 4 people, and we're going to place them each on the Ferris wheel. Now we have the coding portion. It wants us to connect the hub, and then it wants us to make the program. So I'm pulling up a play block here, a block for speed, a block for a loop, and the block for the angle. Oh, even I make mistakes, it seems. So here we go. Slip that in there. And now we can change our program. We can upgrade our program. And it gives us a lot of creativity to modify this any way we want to get the most out of this lesson. So let's circle back to LEGO Spike. LEGO Spike is geared towards older students and more advanced students. It requires more math skills, like the knowledge of the XY axis, percentages, and decimals. It includes more complex builds, like our breakdancing robot, and introduces bigger programming concepts, like variables, functions, and loops. All right, so let's circle back to Spike Prime. So we're going to click here, and we're going to go back to Units. We're going to scroll down to Life Hacks here. We're going to pick the Breakdancer. So the instructions are to get up and dance. And you can see here we've got our coding environment, motors, lights, events, control, and music. So we need to press forward on this arrow, and then we got to build our Breakdancer. So I'm just going to quickly flip through these instructions. So we got to build the legs and base first. And you can see it's step-by-step how to put them together. Then we do the top half, same thing. And nearly there, we've got the light sensor for the head, and he's built. And it gives us this little chart that tells us the appropriate letter and where it should be plugged in. So now that that's done, we exit out of here, we press forward, and we connect our hub. So here's our code. So what this program says is when the program starts, motor F will go to 80% of its total speed. It's going to go its shortest path to position 0. It's going to wait 1 second. Then it's going to broadcast go on the battery pack light matrix. At the same time, a loop of motor F going counterclockwise for one rotation and waiting for 1 second is going to take place 10 times because of this repeat block right here. Simultaneously, when the robot receives the go message from the first block, it's going to do a repeat of 10 times of going 1, 2, 3, print it out to the light matrix for 1 second apiece. And with that, our robot is pretty much done. So we can continue on by trying to figure out how to make the robot swing his arms. And we're just going to open the hint and look at the code here for now. So we can exit that and proceed forward. And you can even add music. You can make him dance to the beat. You can make his legs move. And then it asks us how did we do. And I think we did okay. And with that, that concludes Lego Spike.
Yay!
Hi, I'm Thatcher from the SDM Foundation, and I'm going to show you quickly what our Scratch lessons are like when we do summer lessons that are geared towards kids. We have two different tiers of Scratch lessons, in a beginner and sort of an advanced class. So in the beginner class, we would start off with the tutorials to get an idea of what Scratch is, because it's block coding, and when you have a goal that you're supposed to attain, makes it a lot easier to get a grasp of the concept. So if we were to follow through this tutorial, we would add a backdrop by doing exactly what the little tutorial is showing us. I'm choosing something that's not recommended by the tutorial, but it's just to show the point. Then you can add other things like sprites, which are the movable pieces or characters. Then we add the important bit, which is the coding. So over on the left-hand side is where we have all of our different, block groups. So it wants us to go to events, and when a certain key is pressed, because we're able to change what key, something happens. So something happening in this case is going to be changing the x coordinate by 10. Positive 10, which means that if I hit the right arrow key, the cat's going to move over. So it starts off, nice and simple in terms of the actual block coding, although because it's something that might be conceptually beyond what they're learning in school, it's still, something that really needs to have these two separate tiers, because you can eventually do some very, very intense projects. So the project that we're loading now is something that was created by someone on Scratch. Unfortunately, I did not grab the name, so no credit goes to them, but this is not my making, and there are tons of really impressive Scratch projects out there. So this might seem like, hey, what the heck's going on? This seems like a pretty weird or blank code, but this is more of just because of how detailed the project is. So if we see over here in the bottom right where all the sprites are, each sprite is going to have different codes. So when we go to something like the player, he has quite a lot of code blocks here. So as you can see, it can get extremely elaborate, and the results can be equally extreme. And this, as some of you, or hopefully all of you, because of how long it's been around and its popularity, know about Mario. So someone was able to recreate Mario to an extreme extent when it comes to every aspect of the traditional platformer, and potentially even implementing joysticks. So you could use a controller, but basically, the sky's the limit when it comes to Scratch. But uh, so when we approach an advanced lesson, we try and get out of the tutorials and have them develop an idea of what they'd like to achieve. Sometimes it might be a bit too grandiose, but the process of approaching that and seeing what it would take to actually make happen is worthwhile learning experience and something that helps them understand how to actually achieve their goals, or maybe rethink their ideas to something that they're more capable of at the moment. And sometimes drawing on you know uh, thing references like this for inspiration, like if someone were to analyze the coding here, they'd be able to potentially uh, figure out how this person handles movement. And at the moment, I do not see it. So it could be based on the background or a bunch of different things, because there's lots of different ways to go about it. But generally speaking, that is pretty much what it comes down to when we teach our Scratch lessons. Um, some of these concepts might be ones that they'll learn eventually in math. But either way, we get them to think about it in a coding mindset. And that is becoming uh, more and more useful in society as we advance continuously into the technological age. All right. Thanks for watching. Now that we've opened up Adobe Rush Premiere, this is the first screen we see. And from here, we could create a new project. But what I'm going to do is go ahead and select on this project I have here, which is one that I have worked on during these video editing lessons. The goal of how I approach these lessons is to first explain how this program is very similar to most other video editing programs because of a few basic functions slash layout. So what I mean by that is that we have a timeline. So this bottom area here where we have these layered rectangles, this is the timeline. And we call it that because, as you can see, it starts at 0 and goes all the way until the end of your recording. And it does so via time. So this is 15 seconds, 30 seconds, 45 seconds, 1 minute, and so on. And this timeline allows you to put various media or pieces of what's going to make up the final product onto the timeline where you want them to appear. And as you can see, we might have multiple things all happening at the same time. So the order in which they're placed on the timeline is also the order in which they appear, meaning that the bottom of the timeline is the bottom. It's below everything else, as if the screen's a piece of or a table. The bottom piece is the first piece of paper on the table, and then this second piece that is now highlighted yellow, that would be the first piece on top of the bottom piece, and so on. And this applies to almost every video editing program. There is a timeline that functions extremely similarly. We can also zoom in and out by changing this bottom bar here, so that we can either really expand on 1 second to get some real detail, or we can zoom out so that we can grab a bigger chunk all at once. See, now I can see the entire video just on one screen, whereas if I zoom back in, I cannot, right?
And these are things that apply to, like I said, pretty much every video editing software that there is. So one question that is left unanswered here is how you get these pieces of media into the video onto the timeline so it's can be manipulated as you see fit. Well, that's what we have up here in the top left, and usually that's exactly where it is. It's on the left-hand side. It will have its own sort of panel, which is going to open up as soon as I decide to add some sort of media. And here we go. Here's the panel that opens. So I can browse through some of the built-in media, such as some of the titles, overlays, or I could, go to My Media. So take things from the machine, audio, either recorded or, something that's an audio file on my computer, or some of their, pre-made audio files as well. Or I could record something right now to put in the video. And once again, this is similar to how lots of other video editing programs work, where you will be able to add your media to the file and then bring it in and out of the video as you see fit. Whether it's as the whole piece of media, like if it's a 5-second clip that you want in your video, you can bring the whole thing in, or you can bring it in, cut it down just a piece, etc. So explaining that kind of thing, which is pretty common and similar across the board, is something that I think is the most important thing to go over. And the next thing, well, I suppose this is sort of still part of like a layout similarities. There's going to be a screen or a preview area that shows what your current video looks like at the playhead. The playhead is this blue line here that moves along the timeline. So wherever the playhead is at, that is what you are currently seeing in the preview area. So over on the right-hand side, we have the ability to do a bit more with our pieces of media. So whereas we can add different media on the left-hand column, on the right-hand side, we are able to open up a different column here that is about uh, similar things in the sense of like adding a graphic. It's not too different from some of the stuff you can do for media. But we'll sort of ignore that one and do something like this. So like effects, right? So if you wanted to add a type of transition to a frame, still not the best example because transitions exist on the other side as well, but pan and zoom, right? So that's something that doesn't exist on the left-hand side because what you're doing is taking a clip and then deciding how it is being moved. So for example, the clouds I have here, I set them to pan and zoom so that it looks like they're moving. So when we play the video and we speed it up a bit, you can see that the clouds are moving. That's because I told it to pan and zoom from the top to the bottom, and then I repeated it. I think I might have reversed it on the back end. But either way, that's the idea. This is where the camera starts, just in that box, and then it finishes down there at the end area. And this is an effect or a way to manipulate the media that you add to your video file. And there are various other types of ways that you can interact and change the media. And those all have their own designated area. And that's basically all it comes down to. In the actual lessons, it would be about helping someone get a better idea of how to make their imagination become reality in the video, or talking about maybe a feature they thought was cool and how they could implement it in what they want to do. But a lot of that comes down to whatever the student wants to create, and sometimes they don't necessarily have an idea of what they want to do. So we sort of just go with the flow and make the best out of it.
Hello everyone, this is Peter from the SDM Foundation. Today we will be talking about Arduino. So Arduino is a general term for programmable boards that output electrical signals. If you tinker with sensors and lights in any way, you'll use them as to function as the brains for the electronics. They are cheap. A lot of them go for about $5 to $25, and a lot of engineering fields use them for prototyping. You can use them for functional items such as printed circuit boards and lights, or you can use them for more fun applications like remote cars and costumes. So, in the Arduino beginner class, we utilize a custom kit of parts that results in a car with a distance sensor. So the car will move forward until it gets really close to an object, and it'll move back, turn around, and keep on moving. It works by having an Arduino communicate to the distance sensor and a motor driver, which combines both the signals from the Arduino as well as an external power supply and converts that to power for the motors so they can do what we want to do. Here is a small snippet of the full wiring process. There are labeled pins in the motor driver that you'll match with the Arduino. So, now that you have the car wired up, we can open MakeCode, the programming software that our board uses. It uses JavaScript coding in the form of block codes, so it makes it really easy for beginners to make great programs. To get adjusted to the MakeCode software, MakeCode does provide built-in tutorials, which I would recommend going through the first few. So, to make the car work, we would enter in the preset move-in functions into this cyan blue if-else statement. This statement is asking when the distance sensor gets real close to an object, it will perform this specific function. And in any other case, it will do another function. So what we want it to do is when the car gets very close to an object, it will move backwards and then turn, and then continue on moving forward. So to make the car work, we would enter in the preset move-in functions into this cyan blue if-else statement. This statement is asking when the distance sensor gets real. So now that we're finished with our code, we will plug in the board to the computer and hit upload, which should be a big purple button on the bottom left of the screen. Once that's uploaded, you should see a motor move forward. And if you stick your hand very close to the distance sensor, it would probably do another set of instructions for a short period of time.
Hello everyone, I'm Finn, I'm from the SDM Foundation, and today we're going to be talking about Procreate. Procreate is an app specifically on the iPad and for iPad OS, and it is essentially a drawing app. So if you do art, if you do drawing, some type of graphic design stuff, it is the kind of like the industry standard for drawing on the iPad. You can use an Apple Pencil for it, which is probably the best feature that it has. And you can also use it for animation. So if you want to make like a short little cartoon, you can do that as well. I have my Apple Pencil synced to the iPad. I'm going to tap on Procreate. Here we are. We can see all of our drawings, projects that we've worked on. If you want to continue one, you could just tap on it and open it up. If you want to make a new drawing, a new project, you're going to click the plus here, which is at the top right. These are just the sizes of the canvas that you'll be working on. So let's just click on screen size for now. On the top right, I can select my color. I can slide here, I can slide here. On the left here, or on the top, sort of, this little paintbrush indicates that we are in drawing mode. So if I'm using my Apple Pencil to draw and draw these lines. If I want to change the brush, I tap on it and I can select something else. And they have all these categories here on the left. So let's say I want to switch to a pencil. I just tap, I tap outside, and I can start drawing. Also, it's pressure sensitive. So I can draw on the side like this for shading. The harder I press, the darker the color will be. So drawing lightly, and the harder I press, the darker it is. If I made a mistake, these little arrows here on the right, I could just click back up. Here. I can also select opacity. So this is 100% opacity. If I lower it, it becomes a little bit more translucent. And the further down I go, obviously until you can't see it anymore. And then here's just the brush size. So if I want it like that, a little bit smaller. I also have layers, which is at the top here. Layer 1, so we have our background color. Right now it's white, but let's say we want it this yellow. And click done. Now we have layer 1, and what layers are really good for is if you want to kind of separate the work that you do and you don't want it kind of interfering with each other. So let's say like I want to draw a circle, right? Or I want to draw a ball. So I'm going to draw like the rough outline with a sketch. And now what I could do is just take now a pen and go over it. But that's going to be on the same layer. So if I change anything or erase anything, it's going to erase both. So now what I could do is I can add a layer. Now layer 2, I could trace over. Now once I'm happy with that, I can get rid of layer 1 by unchecking the box and see how that pencil goes away. Now, because we have our inking on the top and our sketch on the bottom, and I'm currently on the inking layer, if I go to erase, it's just going to erase that layer, whatever I put on that layer and nothing else. I'm under Canvas and I'm going to turn on Animation Assist. So let's say we want a little ball to be moving. So here on the bottom we have all of our frames. I can add more. Let's just do that for now. And I swipe back to get to the first one. So we have a ball here. Then what I could do is I can tap on the next frame, have it move over a little bit, tap on the next one. And what's really useful is that you can see all the previous frames before it. So if you have a detailed drawing, let's say of a person, you can still kind of somewhat trace over or reference what the other frames looked like. So now if I play it, it looks like that. If I press settings, I can lower down how fast it plays. So let's go to 5 frames per second. And then it'll just continue to play like that. I can also rearrange frames like this if I hold and drag. Now if I play, it'll play in a little bit different order.
Hi, I'm Anthony from the SDM Foundation. In this video, we're going to talk about Tinkercad and what we teach our students over the summer and during school vacations. First thing we're going to do is go to tinkercad.com. We're going to sign into our account. We generally have our students create their own account before they come in, but if they aren't able to, they can just use our account. We're currently under our account's designs page, where we can see 4 designs that some of the students have created. To make our own design, we're going to click on the blue Create button and we're going to click on 3D Design. Here we're going to see our work plane, some tools on the right, as well as our basic shapes underneath. Right click on the work plane to move it around, or use the square up the top left. Use the plus and minus or the scroll wheel to zoom in, and then the bottom button will let us see the work plane flat. On the right side we have our basic shapes. This has creatures, it has electronics, certain designs, hardware, all sorts of preset shapes that we can use on our 3D work plane. This summer we started having our students make keychains, so I'm going to show you how to quickly do that. The first thing we're going to do is choose a base shape. To make it easy, we're going to choose the square here, the box, and we are going to drag it into a shape that we can use. To show how some of the tools work, the arrows left and right will let us rotate it. The arrow above that is going to let us drag it up and down on a 3D plane. This is underneath the plane, this is above the plane, which is important when you're layering things. But for now, we're going to use the squares to manipulate the shape so that we can have a good base for our keychain. We're going to flatten it out a bit, and we're going to drag it up, and then we're going to drag it to the left to make it larger. So this is a solid base. You can also use those sliders on the right. You can make it a hole in a design. You can change the colors of it. All sorts of stuff there. You can lock it. You can hide it. That's all the control over the shape you're currently editing on the right there. So We have a decent base. We're probably going to make it a little bit bigger here so that we can fit all our text on there. And then we're going to go back over to the shape area. We're going to choose the text option. Once the text shape is out, I'm going to put it over the base, and I'm going to use the arrow at the top to give it a little bit of texture. We're going to move it out a bit. And then on the right here is where we can change what the text actually says. You could probably do this first so that when you're placing it, you can see, if it's too big or not. But this is only 3 letters, so I'm going to click it. I'm going to make it bigger so that it fits perfectly onto the base. Now that I've centered it, I'm going to move the work plane and see that I've made the text just too big. We don't need it to be shooting out so far like that. So I'm going to pull it down a little bit, keep a little texture there without it being too much. So now that we have the text where we want it, we need to add the keychain's hole. To do the hole, I'm going to select any shape on the right that is circular that already has a hole cut out into it. I chose this one, and I'm going to pull it up off the plane a little bit so that it's centered in that way on the base. Next, I'm going to make the hole the size I want it to be, and then I'm going to drag it over to the base, make sure it's touching. I kind of put the circle in a little bit, which is what you want to do to make sure that they actually connect to each other. Now that I've finished the size of the hole, I'm going to change the color. Unless your 3D printer prints in multiple colors, it doesn't really matter, but for the design's sake, keeping it the same color is pretty good. So now I click on the ruler tool and I look to see if it's level. Clearly it is because I didn't really rotate anything. So the last thing I'm going to do now is just add some stars to it, just to show you can add other shapes to the design, and that the shapes don't need to necessarily be on the base of the design. You want to make sure there's good enough contact so that it will print properly. If there's not enough contact, it might not print right. But as long as there's no gaps when you rotate the work plane, you can see that it's touching and that it'll print properly. Obviously, there's a lot more you could do with this program, but this was just meant to be a quick introduction into what we do with Tinkercad in our lessons over the summer. Thanks for watching, and I hope this was helpful.